So hello and welcome everyone. Welcome to Kreatryx. Welcome to Unacademy. So in these sessions, we are going to start the communication system and you are going to study the communication system like never before. So before that, let me introduce myself. My name is Vishal Soni and I have cleared ESE examination 2 times, both times in double-digit rank. And I have also served as a Group A gazetted officer in Indian Railways and in Indian Telecommunication Services. And I have also cleared a lot of public sector examinations. So right now I'm teaching on Unacademy and I really feel proud to be the part of the Unacademy team, because Unacademy is the revolution in the field of free education and in the field of affordable education, and we as a team are really looking forward for every student to just come onto the Unacademy platform. You can attend the special classes, you can come onto this YouTube channel and you can stay connected with us so that you can understand the quality education and you can understand the efforts that we are putting in, so that every student of this country, whether he stays in a village or he stays in a town, should get the access of the content, that too in a very affordable prices, and he can also or she can also clear the examination with the best possible ranks. So right now I'm teaching on Unacademy with more than 15 million watch minutes in the overall duration and 2 million watch minutes in the last 30 days. So I am right now the top educator in Unacademy across all the branches, having rank 4 right now. And you can also follow me on Unacademy on this particular link. So you can go and follow me on Unacademy. Apart from that, my advice to every student is that how should you crack the examination and what are the components to cracking the examination. So the first question that comes to the mind, that can anyone prepare from the YouTube? Yes, you can prepare from the YouTube, but you should develop or cultivate some habits in yourself. For example, you should be very much disciplined. You should arrange the extra resources. For example, the PDFs you have to arrange, the test series you have to arrange by yourself, and most importantly, that self-discipline you should be containing in yourself, so that you can be very corrective manner and you can approach the examination in the best possible manner. So all these things you have to arrange yourself. The sense of competitiveness you have to cultivate in yourself, because the audience on the YouTube are not that much of competitive in nature, or maybe you cannot feel the competition which is present right now. So all these things are the part of the journey if you want to prepare through the YouTube, or maybe if you want to prepare through the free resources. Apart from that, if you want that you should get complete content, then this is the YouTube channel. On this YouTube channel itself, all the free content are available. You just have to go to the playlist. All the subjects are completed there. You just have to go and watch all the lectures one by one. Definitely will be getting benefited. But the extra things that I have told you, that the self-discipline and the sense of competitiveness and a lot of things you have to arrange by yourself. If you are comfortable in that, then you can do that. Apart from that, you should also have Unacademy learning app, so that the special classes you can attend. A lot of educators in this country are actually providing the special classes, that too absolutely free of cost, so that you can get the quality content in the best possible manner. Apart from that, there is also another component for you, which is Unacademy Plus. So on Unacademy Plus, what is your job? You just have to study. If you join this Unacademy Plus, you do not have to worry about the crash courses, weekly test, doubt solving sessions, the language barrier, rank improvement batches, live classes. So all these things will be taken care by the Unacademy. You just have to take the Unacademy Plus subscription and you have to come on to the Unacademy. You will be daily getting the live classes. You will be getting the crash courses. When you will be getting the crash courses? When the syllabus are completed. You will be getting the weekly test in the form of quizzes. Every fourth class is the doubt solving session, which is the major you can say the component or the major impact will be creating on your studies will be this doubt solving group. Because until and unless your doubts are not being cleared, until and unless you are not able to clear your doubts, you will never get the confidence in the subject. So once you come on to this Unacademy Plus, every fourth class is doubt solving session. Apart from that, various other doubt solving sessions are going on. So ultimately you will be getting your doubts cleared and you will gain confidence in the subject. The language barrier will not be an issue, because the batches will be running both Hindi and in English, and rank improvement batches will also be there. So all these things are the component of this Plus subscription. Once you come on to this Unacademy Plus, you do not have to be worried about your self-discipline, your competitiveness nature. Everything will be present on Unacademy, because a lot of other students will be there. Since the classes will be live, you can also watch it recorded later on. So the discipline automatically comes, because you get the idea that you will be having the daily live classes. Apart from that, there is also one iconic subscription. In this iconic subscription, the game changer is this personal coach. So this subscription is for them who thinks that their basics are weak, or those who are talented but they needs a continuous push. So this personal coach will be guiding you throughout your strategy. He will be giving you the study planners. You will be getting the study booster sessions. Once you will get the test, you will be getting the analytics. Analytics plays a major role in improving yourself. We as a teacher also get our analytics so that we can improve on the daily basis. So once you start getting the analytics, you will be also improving massively on the daily basis. Apart from that, there will also be the guidance for the mains once you clear the prelims, and there will also be the guidance for the interview once you clear the mains. So once you take the Iconic subscription, all the benefits of the Plus are included by default in this. And if you
Hello friends, so in the last lecture we studied about the instantaneous sampling, and we did time domain as well as frequency domain analysis of instantaneous sampling. So in this class, what we will do the spectral analysis of instantaneous sampling. So again, let me consider this x of t to be the low pass signal. So I can assume the spectrum of low pass signal, which is x of f, in the sense that it contains a low pass spectrum, something like this, and it will be from 0 to fm. This will be minus fm, and peak value you can consider it as x of 0. Now we know that when we multiply this x of t with an impulse train, which is del of t minus nts, then we get the sampled signal y of t. And the spectrum of this y of t is y of f, which can be written as fs x of f minus nfs, where n can vary from minus infinite to plus infinite. Now if I will expand this summation, so I can write it as x of f plus fs when I will put the value of n as minus 1. When I will put the n value 0, then I can write x of f. Then you can write it as x of f minus fs plus up to infinite. So from here we should notice that if we want to draw the spectrum of sampled signal, then we must draw x of f and multiply the spectrum with fs. So we will draw the same spectrum of this x of f, and I will multiply it with fs. Similarly, you should shift the graph of x of f by fs unit rightwards in order to draw the x of f minus fs. You should also shift your graph of x of f by fs unit leftwards in order to draw this. So you can see from here that whenever you are trying to draw the spectrum of the sample signal, you have to basically shift the spectrum of this x of f by fs unit, 2fs unit, 3fs unit, both leftwards as well as rightwards. So this is the idea behind the spectrum of the signal. Now let me give you the basic setup of sampled signal as well as its transmitter and receiver. So suppose we have the signal x of t. So at the transmitter, what we will do, we will sample the signal, and to sample the signal we know that we will multiply it with a carrier, and the carrier is del of t minus nts. So after multiplying, you will get the sampled signal y of t, which is x of t del of t minus nts in time domain, or I can write it as fs summation of x of f minus nfs, where n can vary from minus infinite to infinite in frequency domain. So we will transmit these samples to the receiver. So receiver will receive either this y of t or y of f. We know that since our message signal or the transmitted signal is low pass in nature, so we will place a low pass filter here, and let me call the output of low pass filter as y naught t or y naught f. So the basic purpose will be completed if this x of t is sampled first, then it is transmitted to the receiver, and the purpose of the receiver must be that it should recover this mx of t from the transmitted signal y of t. So this y naught t or y naught f should be equal to x naught t or xf. So this is the basic purpose of sampling, that you should be able to sample your signal x of t in order to generate y of t or y of f. Now this y of t or y of f is being transmitted to the receiver, and the receiver has to recover the low pass signal x of t from it. So to recover the low pass signal from it, it will place a low pass filter, and the output of the low pass filter I am assuming to be y naught t or y naught f. So the sampling will be considered as successful only when this y naught t or y naught f will be received as x naught t, or which is will be received as xt or x of f. So this is the basic setup of sampling. So I will consider 3 different cases in that, and for each case we have to consider the transmission as well as reception of the sampled signal. So first case I am considering, in case 1, I am considering that the sampling frequency is greater than 2 times of fm, where fs is sampling rate and fm is maximum frequency present in x of t, or the frequency at which x of t is band limited. So basically you have to consider 2 different cases, 2 different frequencies, which is fs and fm. Now I can also write it as fs minus fm should be greater than fm. So I can also see it like this, that fs greater than 2 fm means this fs minus fs has to be greater than fm. So first of all I will discuss at transmitter. At the transmitter, we know that if the spectrum of x of t is x of f, which is this spectrum from minus fm to fm, this is x of 0. Now in order to obtain the sample signal y of t, we have to multiply x of t with an impulse train del of t minus nts, and it will give the sampled signals spectrum as fs into summation of x of f minus nfs, and I will write it as fs into x of f plus fs plus x of f plus x of f minus fs up to infinite. So I will draw the spectrum of YF. So first of all I will plot this x of f. So this x of f will be something like this. It is from minus fm to fm, and the peak value will be fs into x of 0. Then I will shift the spectrum by fs unit rightwards. So whenever I will shift the spectrum by fs unit rightwards, this frequency will reach to fs minus fm, and we can see that fs minus fm is greater than fm. So the fs minus fm will come something here. It should be greater than fm. Similarly, this 0 frequency will reach to fm, and this will reach to fs, and this fm will reach to fs plus fm. So this will be the fs into x of 0, or this is the spectrum of x of f minus fs. Similarly, when we will draw x of f plus fs, then this spectrum will be shifted by fs unit leftwards. So it will become minus fs minus fs minus fm minus fs plus fm, and the peak value can be considered as fs into x of 0, and we will get this spectrum which will extend up to infinite number of frequencies. Now you can see from here that the 2 adjacent spectrums, which means the spectrum of x of f and x of f plus fs, are not overlapping with each other, which means they have enough spectral spacing between them. So this is the spectrum of x of f, and this is the spectrum of f of x of minus fs, and this is the spectrum of x of f plus fs. and you can see that these three spectrums has sufficient gap between them, or they are not overlapping with each other, and this gap is known as guard band. So this gap is known as guard band. Now this is the sampled signal at the transmitter. Now we will transmit it to the receiver. So at receiver, we basically know the setup. At the receiver, it will receive this Y of f and it will pass it through a low pass filter. So let us consider the characteristic of the low pass filter is h of f, and the output of this low pass filter I am considering as y naught f. So this is the spectrum of yf, the peak value is fs into x of 0. This is 0, fm minus fm. This is fs, fs plus fm, fs minus fm. This is 2fs. Similarly, this is minus fs, minus fs plus fm, sorry, minus fs minus fm, and this is minus fs plus fm. Now we have to pass it through a low pass filter. So this is the characteristic of the low pass filter. So I am assuming an ideal low pass filter, and let the cutoff frequency of the ideal low pass filter is fc minus fc, and I am assuming the pass band gain as 1 by fs. So whenever we have to obtain the y naught f, we know that y naught f is nothing but yf into h of f. So whenever we will multiply this yf into h of f, we will obtain a signal which is minus fm to plus fm. This is y naught f. Since it has the pass band gain as 1 by fs, so this 1 by fs is multiplied with fs, and we get the peak value as x of 0. Now very clearly you can see from here that this y naught f exactly matches with the spectrum of x of f. So we are able to again reconstruct our signal from the transmitted signal. So we sampled the signal x of f in order to obtain this y of f. Then at the receiver, we are able to recover back our x of f by using a low pass filter. So you can see that the characteristic of this low pass filter should be that its cutoff frequency should be greater than or equal to fm and less than or equal to fs minus fm. So from here you can say that the low pass filter must have a cutoff frequency which is lying between fm to fs minus fm. So this is also a very important conclusion, that you can use the ideal low pass filter, but this ideal low pass filter must have the cutoff frequency between fm to fs minus fm, because if I will use a low pass filter something like this or something like this, then basically we have to use our low pass filter in such a way that it is able to transmit only this much of spectrum, and it should not allow the adjacent spectrum which is starting from fs minus fm. So it should allow only this much of spectrum, which is the spectrum of the transmitted message signal, or x of t. So in the first case what we studied, we said that at transmitter, whenever fs will be greater than 2 times of fm, then adjacent spectrums in spectrum of yf will not overlap. And at the receiver, we said that if the low pass filter has cutoff frequency from FM to Fs minus Fm, then X of F can be recovered or reconstructed from Y of F. So, to reconstruct X of F from Y of F, following two conditions must be met simultaneously. The first condition is that Fs must be greater than 2Fm so that adjacent spectrums do not overlap, and second, that at the receiver the cutoff frequency of low pass filter must be between Fs minus Fm to Fm. Now if I have to apply a restriction on Fs, then I can see that the first restriction on Fs is that Fs must be greater than 2Fm, and the second restriction is Fc is less than Fs minus Fm. So from here you can also see that Fs must be greater than Fc plus Fm. So the sampling rate must satisfy two conditions. So if I have to apply a condition on sampling rate, which is f of s, so the condition can be that Fs must be greater than 2 times of Fm, as well as it must also be greater than Fc plus Fm. So whenever these two conditions will meet simultaneously, then we will always be able to recover our transmitted signal x of t at the receiver. Now let us discuss the second case. In the second case, I am assuming that this Fs is equal to 2 times of Fm, where Fs is nothing but sampling rate, and f of m is the frequency at which x of t is band limited. Or maximum frequency component or maximum frequency of x of t. So in this case also we know the spectrum of x of t, which is x of f. So this is the spectrum of x of t, and it will exist from minus fm to plus fm, and this peak value you can consider as x of 0. Now if this x of t is multiplied with an impulse train in order to obtain the sampled signal y of t, then we can get y of f as fs into summation of x f minus nfs, and you can expand it like this. So you can call it x of f plus fs plus x of f plus x of f minus fs up to infinite. So here also you have to draw the spectrum of x of f minus fs, x of f plus fs, and so on. So you have to draw the spectrum of all these components. So now let me draw the spectrum of yt. So first of all, I will draw this x of f. So the spectrum of x of f will be similar to this, and this peak value will be multiplied with fs. So it becomes fs into x of 0, this is 0, fm minus fm. Now in order to draw this x of f minus fs, I have to shift the spectrum of x of f by fs unit rightwards. So this frequency will reach to fs minus fm, and from this condition you can see that this fs minus fm in this case is exactly equal to fm. So whenever I will shift it rightwards, this frequency will be fs, this will be fs plus fm, and the fs minus fm will exactly overlap with this fm. Similarly on the left side also we will have spectrum something like this. So this will be minus fs, this will be minus fs minus fm, this will extend up to infinite, this will also extend up to infinite. So from here you can see that in the last case when we considered that fs should be greater than 2fm, then we were getting the enough spectral spacing between adjacent sidebands or adjacent spectrums. But when we considered fs equal to 2fm, in that case we are not getting any spectral spacing between the adjacent sidebands, or we are not getting any spectral spacing between adjacent frequency spectrums. So here I can say that the guard band which I am considering is going to be 0. So this signal y of f will be transmitted and we will able to recover it at the receiver. So at the receiver, we will have yf, it will be passing through some low pass filter h of f, and we will get the output y naught f should be equal to yf into hf. So first of all let me draw the yf. So this is the yf. This is 0, fm minus fm. This center frequency is fs. This center frequency is 2fs. This center frequency is 3fs. It is minus fs minus 2fs, and all these peak values is going to be fs into x of 0, and this is f. Now we have to draw the low pass filter. So low pass filter must be such that it must be able to reconstruct our signal x of f. So I will draw the low pass filter. In this case we can see that the low pass filter's cutoff frequency must be exactly equal to fm, then only it will filter out only the massive signals spectrum which is from minus fm to fm. So this particular spectrum will be filtered out only when this ideal low pass filter has spectrum from minus fc to fc and pass band gain as 1 by fs. So in order to obtain the y naught f, which will be equal to yf into h of f, we will multiply these two spectrums, and whenever you will multiply these two spectrums you will get the spectrum which will exist from minus fm to fm, and its peak value will be multiplied this 1 by fs with this fs. So we will get the peak value of x of 0, and you can very clearly see that this particular spectrum is matching exactly with the spectrum of x of f. So we transmitted this y of f from the transmitter, and this receiver is able to recover our x of f from this yf. So we can say that it is exactly matching this, and here this fc must be exactly equal to fm. So in the case 2, at the transmitter we assumed that this sampling rate must be equal to 2 times of fm, and in this case we also say that the adjacent spectrum or sidebands in spectrum of YF do not overlap, but they are on the verge of overlapping. So they are on the verge of overlapping, but they do not overlap. And at the receiver, we said that the cutoff frequency should be exactly equal to FM. Then X of F can be recovered or reconstructed from Y of F. So to reconstruct X of F from Y of F, we need two conditions. So the first condition comes out to be Fs equal to 2Fm, and second condition comes out to be that the cutoff frequency should exactly be equal to Fm. Now if we have to see any condition on Fs, then here only one condition will be on Fs, that Fs should be equal to 2 times of Fm. So this condition is also very important. Now let us try to discuss the case third. So in the case 3, I am assuming that Fs is less than 2 times of Fm, or I can call it as Fs minus Fm should be less than Fm. So this is the third case. Now again, at the transmitter, we know that the spectrum of X of t is a spectrum of low pass signal. So I can draw the spectrum of X of t something like this. From minus Fm to Fm, this can be X of F, and this frequency can be considered as X of 0. This is 0. Now we know that the sampled signal Y of t will be obtained when this X of t is multiplied with an impulse train, which is del of t minus nts, where n varies from minus infinite to infinite. So we get Y of f as Fs into summation of X of f minus nfs, where n varies from minus infinite to infinite, or you can write it as X of f plus Fs plus X of f plus X of f minus Fs up to infinite. Now here also we have to draw these three spectrums: X of f shifted rightwards by Fs, X of f shifted leftwards by Fs. So whenever I will draw the spectrum of this Y of f, I will draw first of all this X of f. So this is the spectrum of X of f, which is from minus Fm to plus Fm, and the peak value becomes Fs into X of 0. Now I have to shift the spectrum of X of f by Fs unit rightwards, so it will become, this point will become Fs minus Fm, this will become Fs, and this will become Fs plus Fm. And from here we know that Fs minus Fm should be less than Fm. So the spectrum of Fs, which is shifted rightwards, will look something like this. So again, this frequency will be Fs, this will be Fs plus Fm, and this frequency will be Fs minus Fm, because in this case the Fs minus Fm should be less than Fm. Similarly, whenever you will draw this x of f plus fs, you will get the spectrum something like this. So this frequency is minus fs, this is minus fs minus fm, this is minus fs plus fm, and the spectrum gets repeated something like this. So you will get the spectrum of this type. Similarly, in the negative side also, the spectrum gets repeated. Now from here you can see that this is the spectrum of x of f, this is the spectrum of x of f minus fs, and you can see that the adjacent sidebands are overlapping in this particular frequency, then again it is overlapping in this particular frequency, here also it is overlapping in this particular frequency. So whenever signals are overlapping in this frequency, these two signals will get added, and the resultant spectrum which you will see will be something like this. So this point, then these two will be added, and we can see from here that these two signals are having equal and opposite slope, so they will get add up in this particular region, and after being added, since they are equal and opposite slope, so the net slope will be 0 and they will be converted into a horizontal line. So this line and this line, when we will add, so after being addition of these two signals, the slopes are equal and opposite, so they will get added up, and after being the addition, the slope will be 0 or they will be converted into a horizontal line. So it will become horizontal line something like this. This will be fm, this is minus fm, then again and the spectrum that we will get will look something like this. And this is the frequency minus fm to fm, and the peak value remains fsx of 0. So this is the spectrum of sampled signal at transmitter. So now what will happen at the receiver? At the receiver, we will be getting this y of f, and we will be passing it through a low pass filter having frequency response h of f, and the y naught f can be written as yf into hf. So let me draw the y of f. So we have seen the y of f has format something like this, and so on. Here also, so this frequency becomes minus fm, and it becomes fm. So this is 0, this is fs, this is 2fs, similarly this is minus fs, and so on. So we have to multiply it by h of f, and the spectrum of h of f looks something like this. It is from minus fm to fm, and I am considering the peak value as, or the spectral passband gain is 1 by fs. So whenever I will multiply these two signals, so the output which I will be getting is something like this. So this is minus fm, this is fm, and this is your y naught f having peak value as x of 0. So from here you can see that in this case the y naught f which we have got from here is nowhere matching with x of f. So it is not equal to x of f, which means in this case we are not able to reconstruct back our message signal from the sampled signals. So in case 3, what we did at transmitter fs was less than 2 fm, and in this case the adjacent sidebands in the spectrum of YF will start overlapping, and at the receiver, even if we are able to set the cutoff frequency of low pass filter equal to fm, then also x of f is not reconstructed back from y of f. So in this case, whatever may be the condition on the filter, as long as fs is less than 2 fm, the x of f can never be reconstructed back from y of f. And whenever fs is less than 2 fm, the adjacent sidebands in the spectrum of YF will start overlapping, due to which we are not able to reconstruct back from x of f from YF, and this phenomenon is known as aliasing. So this phenomenon is known as aliasing. So the spectral overlapping which we did in this case here, this spectral overlapping phenomenon is known as aliasing. So whenever fs is less than 2 fm, then in all that cases the adjacent sidebands will get overlapped, and due to which we were not able to reconstruct x of f back from the y of f. So now let us discuss all these three cases. So in all these three cases, first of all, in the case 1, we said that whenever fs will be greater than 2 times of fm, so in that case we will transmit this x of t, which is del of t minus nts, and this yf will be converted into fs summation of x of f minus nfs. So this will be transmitted to the receiver, and if receiver has low pass filter whose cutoff frequency is between fm to fs minus fm, then the output of the low pass filter y naught t will be exactly equal to x of t, and the low pass filter should have cutoff frequency in this range, and it should also have pass band gain equal to 1 by fs. Similarly, here you can see that when it is transmitted to a receiver, where receiver is having a low pass filter which has cutoff frequency between fm to fs minus fm and pass band gain equal to 1 by fs. So in this case y naught f will be equal to x of f. This condition of fs greater than 2 fm is known as oversampling. So whenever we are able to perform the oversampling or fs is greater than 2 fm, you should remember this flow, that we will transmit this x of t into summation of del of t minus nts, And at the receiver we will have low pass filter whose cutoff frequency is from FM to Fs minus Fm, and pass band gain is 1 by Fs. So sometimes this pass band gain you can also write it as Ts. You can also write it as Ts. So in both the cases you are able to recover your x of t as well as your x of f. And if we have to put a condition on Fs, so condition on Fs in this case will be, first Fs should be greater than 2Fm, and also Fs should be greater than Fc plus Fm, where Fc is nothing but the cutoff frequency of the low pass filter, where Fc is cutoff frequency of low pass filter. So this is the summary of the case 1. Similarly, for case 2, we were considering Fs equal to 2Fm. So in this case we will transmit this x of t summation of del of t minus nts. In this case we will have receiver at the low pass filter. We will have a low pass filter at the receiver, and this low pass filter must have cutoff frequency exactly equal to Fm, and the pass band gain should be equal to 1 by Fs or Ts. So in this case the output of the low pass filter will be exactly equal to x of t, or the y naught f will be exactly equal to x of f. So you can also write here y of f, which is f of s times summation of x of f minus nfs. And if we have to put one condition on f of s, then condition on f of s should be exactly equal to 2 times of fm. Now this condition is known as critical sampling. Now let us understand the case 3 similarly. In the case 3 you were saying that Fs must be less than 2Fm. So in this case also we will transmit x of t del of t minus nts, or Fs summation of x of f minus nfs. So at the receiver, whatever the low pass filter it has, it is never able to recover the signal x of t, because aliasing will occur in this case, which will disturb the spectral components. That is why we are not able to reconstruct our x naught f. This condition is known as undersampling. So whenever Fs is greater than 2Fm, or the case of oversampling occurs, in that case the signals will not overlap in frequency domain, or the adjacent sidebands will not overlap in frequency domain, or there will be no aliasing, and we will be able to recover our signal x of t. So whenever the oversampling occurs, then x of t can be reconstructed if the cutoff frequency of the low pass filter is from Fm to Fs minus Fm. Similarly, if Fs equal to 2Fm is written, or it is the case of critical sampling, then x of t can be reconstructed if the cutoff frequency Fc is equal to Fm. Similarly, if Fs is less than 2 Fm, or which is the case of under sampling, in that case x of t can never be reconstructed whatever may be the condition on filter. So whatever may be the condition on filter. So based upon the above discussion, we can form a low pass sampling theorem. So this is low pass sampling theorem. So according to this theorem, a low pass signal can be sampled at transmitter and it can be reconstructed by its samples at the receiver only when sampling frequency or sampling rate is twice the maximum frequency present in low pass signal. So if this x of t is low pass signal and the maximum frequency present in it is Fm, then Fs should be greater than or equal to 2 times of F max. So from here you can say that minimum sampling rate is 2 times of F max, and the minimum sampling rate is known as Nyquist rate. So the minimum sampling rate is also known as Nyquist rate. Similarly, you can calculate this Fs should be greater than or equal to 2 times F max, or you can say that 1 upon Fs is less than or equal to 1 upon 2F max, or I can write Ts should be less than or equal to 2F max, where Ts is sampling interval. So you can also say that the maximum value of sampling rate will be equal to 1 upon 2F max, and it is known as Nyquist interval. So we obtained two new terms. First one is Nyquist rate, and Nyquist rate is two times F max, or it is the minimum sampling rate. Similarly, you can also define Nyquist interval, and it is equal to 1 upon 2 F max, and you can call it as maximum sampling interval. So these were the few important terms which we should remember, and in the next class we will see how to calculate the Nyquist rate or Nyquist interval for few standard signals. Thank you.
So hopefully we have understood every concept in this class. If you have any doubt in any concept, you can let me know in the comment section. I'll try to resolve that thing. Apart from that, you can also follow me on various social media platforms. For example, you can join this Telegram group where you will be getting important notification, important updates. This is Telegram group where you can also comment, you can ask your queries, or maybe you can also suggest me for the improvement. Apart from that, this is my Unacademy profile. On this Unacademy profile, you should also follow me so that you can get the important updates of the Unacademy also, right? And this is the Notion page. You just have to type this tiny.cc/VishalGate. So you will be redirected to a page where all the special classes are arranged very systematically. तो मैंने बहुत सारे टॉपिक्स पे स्पेशल क्लास ले रखी है. फॉर एग्जांपल नाइक्विस्ट, फूरियर सीरीज, latches and flip flop, double integrations, okay, lot of things are there. So you will be getting all these concepts absolutely free of cost. You just have to type this in your URL. You will be redirected to that page and attend these lectures one by one. You will be getting a next level confidence in these topics that I can guarantee you. Now this is the Notion page of your YouTube, on which you will be getting the links of the YouTube. Apart from that, you will be also getting the PDFs of that particular lecture. So this is very important for you, and just you have to type http://bit.ly/GATE live. So GATE live, you just have to type it in the capital so that you can access all the lectures link and PDF arranged systematically. So if you want to attend or you want to clear the examination with the free resource, then this is the channel for you. This is the best recorded videos which has been ever made. You just have to go to that lecture, just click the link and download the PDF and start studying systematically. So we have also done this for you so that any student, whether he is sitting any part of this country, should not face the difficulty in cracking the examination, whether he can afford or he cannot. Now if you can afford, then the subscription prices are not something which you cannot pay. It is very nominal amount which you can pay, and you can just avoid all the distractions, all the time wastage which we will be doing in downloading those PDFs, arranging for the test series, and a lot of other things that you have to arrange, doubt solvings you have to arrange by yourself. If you want to avoid all those distractions in a very nominal amount, so you can go for the Unacademy Plus subscription. For 12-month subscription, you have to pay only 74 rupees per day. Apart from that, for 18-month subscription, which is the best possible subscription, you have to pay 63 rupees per day. It is even lesser than the pizzas that you order on your home. So it is that much of amount that can shape your career, that can give you the best possible rank in the examinations under the guidance of the best teachers of the country, which has been right now placed on the Unacademy. Now 24-month subscription will cost you 54 rupees per day. So these subscription amounts will give you the subscription for the desired period. Apart from that, if you are using this code, you just have to remember this code, write my name, write GATE after it. You can also write ESE after it. So you have to write my name and write ESE after it. So any one of these code, once you apply, you will be immediately getting the 10% discount. You will be getting all the features of the Unacademy. You will be getting the guidance of all the teachers present on Unacademy, and everything you will be getting that is needed to crack the examination once you are using this code. So if you think we are working hard, we are giving our best content, we are giving the free content absolutely for you guys, and everything that is needed for every student to crack the examination. So never forget to use this code whenever you are taking the subscription. So this code is very important and you have to use every time you are taking the subscription. Now those who are interested for the prices, total price amount, so let me tell you, Total price is 27,225 for 12 months, 34,650 for 18, and for 24 months it is 39,600. You can also pay this by using zero cost EMI. Zero cost EMI can be paid by credit card and debit card. In debit cards there are only Bajaj and HDFC as of now available. Okay, so this zero cost EMI means you do not have to pay anything extra. Any interest is not you should not pay, and you have to pay this much of amount on the daily basis if you are looking for the zero cost EMI option. Apart from that, if you are coming for Iconic subscription, so Iconic mein I have already told you that your personal coach will be the game changer. He will be he will be basically following you to give you the guidance so that you can get the success in a very short span of time. So he will be following you, he will be pushing you every time. Now once you use this coupon code, this will be costing you around 45,225, and if you are using this coupon code, write my name, GATE after it, you will be getting the 24-month subscription of Iconic in 66,600 rupees. Fine. Apart from that, every one of you should follow this GATE aspirant group, and there also some important notification always comes. Now what are the YouTube channels that you should immediately subscribe? This Kreatryx, this is the channel on which you are present. This is Unacademy GATE questions, where previous year questions has been solved by the educators. So you'll be getting all the previous year questions video solution apart from the PDF also. This is the Electrical Junction channel, where you will be getting the important concepts of ECE and electrical. And this is Engineering Pathshala, where you will be getting some practical aspect of the videos, some animated videos that will enhance your ability to think. So these are the channels which you should immediately subscribe so that you can get a better content. Fine. Now these are my some YouTube videos which I have created for you. In all of these videos will give you some motivation, guidance, content, and some strategy. So these are hand-picked videos. You can immediately follow these videos. Okay, so thank you so much. And those who are coming on this channel, immediately share all the content which is present on this channel. We are working very hard for you guys. So this is your responsibility that you should share this channel. You should subscribe this channel. Also share the link of this channel, link of the videos, link of the educator whom you follow, so that every student who is needy, they can come onto this channel and they can get the best possible rank. So all the best everyone. Let's crack it.